Welcome back to BAS 120. We're still talking about conditional probability. If you remember the last example, we took our gender and our brand preferences and we did a pivot table. And all I've done here is sort of put these pivot tables into the percent of females who preferred brand 1, brand 2, brand 3, and the percent given that they were a male that liked brand 1, brand 2, brand 3. And then we just simply went up here and, we're able to do some creative. If you go up conditional formatting, you can highlight cells if they're greater than. So I highlighted all the cells that were greater than 50%, and all the ones that were less than 10% I put in red. So you just say highlight greater than, put in whatever you want, and you drop down. You can make it green, light, red, yellow, whatever you want. But this aids, in addition to the pivot table and showing the conditional probabilities, it instantly communicates to somebody, the brand preferences on female are brands 1 and 2, and for the males it's brand 1. So that's the use of conditional probability to help businesses to take a look at which brands are selling given it's a female, or it could be some other demographic or categorical information. Now let's look at example 5.10. It's called the multiplication rule. Independent events. Remember, an event is independent if I'm irrespective of what happened. Probability of A given B is the same as probability A. So another way of saying that is I really don't care what happened in B. It doesn't matter. My events are independent. They're not dependent upon what happened on event B. So, for example, the roll of dice. The fact that I rolled a 5 on the first dice, as long as I don't have weighted dice, the next event is totally independent. It's still 1/6. Flipping a coin, same thing. Shooting a foul shot, same thing. Each event is independent of the next one. So the probability of A and B on independent events is the probability A times the probability of B. Multiplication rule. So the probability of getting an A, a 3 on my first roll, and then a 5 on my second roll is 1/6. The probability of getting a 3 times the probability of getting a 5 is 1/6. So the probability of getting a 3 and then exactly a 5 is 1 in 36. You can do the same thing on cards. The probability of me drawing an ace on my first draw is 4 out of 52. Probability of drawing an ace on the second draw is 3, because there's only 3 left, 3 out of 51. So I multiply those two together and I get something very, very astronomical, unlikely event, because it's very unlikely I draw 2 aces in a row. So that's the law of multiplication and probability. If they're independent events, I can just take the probability of A, event A, times the probability of event B, and that gives me the probability that both events will occur. Now, we have to determine if an event is independent. Well, there's lots of examples. We talked about flipping a coin. Again, 2 events are independent if the fact that A occurs does not affect the probability of B occurring. So I don't care, right? If I flip a coin or purchasing a car, then purchasing a coat, drawing a card from a deck. Now it can get a little gray, right? You could argue, well, if I purchased a car, I don't have enough money to purchase the coat. But the theory is if the probability of that event does not change because of the first event, it stays the same, then my events are independent. So that's let's talk about the law of probability for independent events. There's the law, the probability of A times the probability of B. We've kind of gone through this. Here's an example of rolling a dice, probability of A and B. Let's say what's the probability that I roll a 6? And event B is the probability I roll a 2, 3, or a 12. Now, 2 independent events. Probability of a 6 is 5 out of 36. The probability of a 2, 3, or 12 is 4 out of 36. So the probability if I get both is 20 out of 1,296. Hope that helps. The multiplication law.